Okay, so let's take a look at some examples now where there might be a little bit more work to do, that we can't just look at a picture and see if something is injective, surjective, or bijective. Okay, so take a look at this example. Let's suppose we have the function that maps the reals, so the reals be given by x squared. So is this injective, surjective, or bijective? Okay, so when we look at something like this as an example, we have some strategies. So these are some just helpful strategies that we can work through. So if we want to show that a function is injective, what we're going to want to prove is we want to prove that if f of x equals f of y, then x is equal to y. So it really will follow very much like a proof, where you're going to assume f of x equals f of y, then show me that x is equal to y. To show that it's not injective, this is much more of a counterexample where you just have to find specific choices of elements in our domain where they're not equal, but the function values are going to be equal. Now, to show that it is surjective, we're going to consider an arbitrary element y and b. So pick an arbitrary element in the codomain, and then find an element that exists in the domain that f of x is equal to that. So this is very much like a quantifiable type of proof that you're going to be doing. You're basically saying that for all y in the codomain, there exists an x in the domain such that f of x is equal to y. So here we're going to let y be anything and then find a specific x. X will often depend on y, so we will end up having x be in terms of y. And then to show that f is not surjective, this is going to be much more of a type of counterexample type of thing, where we just have to find some element in the codomain that our function will never be equal to that. So no matter what our x is in the domain, we'll never be able to have the function equal that element in the codomain. Okay, so this is the strategy that we're going to be using. So if we take a look at this one, f of x equals x squared, is it injective, is it surjective, or is it bijective? So usually what will happen is that you'll start to kind of develop some intuition behind these to figure out which one of these do we want to go with. So in this case, to figure out if it's injective, the question is, if I have two elements that I plug into this function, am I always guaranteed to get different outputs? So think about x squared. Well, hopefully your intuition is that there's numbers that give me the same value when I square them, right? So this is going to be a nice example where we're going to find an example to show that it is not injective. So it is not injective. And so what this looks like is we're going to pick 3 and let's pick x is equal to 3 and y is equal to -3. So we can just verify some things, just like with a counterexample, we'll verify them. So here, notice 3 does not equal -3, but f of 3 is equal to 9, and f of -3 is equal to 9. So that's it. So we show that there's two numbers not equal. That's, you probably don't even have to do this most of the time, but showing that the function values are identical, that is an important step. Okay, so that is not injective. Now, surjective, the question is, for this codomain of all reals, is there always an element that when I square it, I can get any other number that's a real number? Well, hopefully your intuition says no, right? So what types of numbers can you never get when you square a number? Well, that's going to be something negative. So it is also not surjective. So again, just like how over here, we just had to find an example, the same thing over here. We're going to find a specific number in our codomain and explain why will we never be able to get an element in the domain to map to that. So let's consider, say, some y equal to, or let's consider y is equal to -1. So this is in the codomain, right? So we know that obviously -1 is in the codomain. Be careful, because sometimes if you don't acknowledge that you're in the codomain, you might be making a mistake. So this is in the codomain, but since x squared is always greater than or equal to 0 for any x that's in the reals, there is no x in the reals such that f of x is equal to -1. So this is what it would look like to just give a nice simple statement here. Pick a number in the codomain, explain why can the function never equal that value, and in this case we just use some simple facts about x squared. So we'll take a look at some more examples of what does it look like if we change up our domain and codomain to see some of these other types of examples.